Hello and welcome to day 23 of this Unity Development Journal. And today was another one of the bigger days I worked on the project here. It is a Sunday again, and I had a few extra hours, not as much as last week, but a couple extra hours to put towards development of this game. And I decided to tackle one of the largest problems for this game, which is the AI pathfinding. Well, not for the entire game, but for this week's of map development is the AI pathfinding. And I'm using an algorithm called AStar, which is one of the most popular pathfinding algorithms available. And it's pretty simple. I've used it in a few Python games I developed. And I'm going to tell you the simplest way to go about this is you can jump over to the wiki page for the AStar search algorithm. And if you come down here, you have some pseudocode here. And it just goes through in somewhat plain English, sort of describing the type of algorithm or the type of steps you're going to have to do in the algorithm. Very well commented. And you walk through, and although it is one of the a bigger kind of algorithm for this type of search, there are some other ones that are a bit smaller. It is quite easy to follow along and build this thing out. Now, like I said, I've ported this over into Python before. In C Sharp, this was the first time I've done that, but it was fairly simple. I followed some other examples, so it was easy to just figure out what to do here. Um, so yeah, you just go through and you just sort of walk through what you have to do, and you put it into code. Here's a nice little GIF describing what happens with the search algorithm. You start in the corner here, and you're trying to get to the green spot, and it just sort of guesses what direction to go, and it tries it. And once it reaches the green spot, it finds the shortest path. It sort of says, boom, I found it, and then there's the shortest path. So that's what the algorithm does, but it does it very quickly as it goes through all the options to get from point A to point B, and then it tells your character where to move in a sequence to get to point A to point B, your destination. So let's go ahead and look at a couple things in the code. So in order to use the pathfinding A-star algorithm, you need to create a graph. Most of these algorithms require a graph. So I started out with you have some basic data types here. So you need first you need a node, which in this case my nodes are going to be built up off the map tiles. So each tile is going to be a node that the character can traverse to get from point A to point B. Now, those nodes have what's called edges, and all edges are is you could think of them as the tile neighbors. So if you're on one tile, what are all the neighbors around you? And in this case, I'm going to have 8 neighbors because I can go diagonally. So you have above you, diagonally left, diagonally down, diagonally right, right? So those are your neighbors, and those are considered the edges. So those are the basic data types that's going to create our tile graph. And our tile graph is generated as soon as we have some sort of a map in place with all our tiles in a grid. I can run that map through this tile graph constructor. So it just goes through, we pass it the world, and all you do is you create a new dictionary for all the nodes. And remember, nodes are right here. These are the node types. So what we're going to do is walk through the map width by the height, and we're going to get the tile at the XY coordinate that we're currently on in our loop. And that's going to be a type of tile, right? And there are things called movement cost, which is sort of what edges use, and that's how the algorithm knows how to move through this thing. So what you can do is set up anything that you can't move through to have a movement cost of say 0, or you could make it like a negative number. And that means that in order to move through that tile, it's going to take this much time type of thing, that this much cost to move through that spot, through that node. And if it's set to 0, you can tell your algorithm to say, "What? Look at you can't. If it's the movement cost is 0, you can't move there, so don't go there." But one thing you can do interesting with that number is you can set it to 1 for it to move through it like a normal space, or you can set it to a higher number like 2 or 3 to say it costs more to move through that space, so like a swampland or a river. And it takes it slows the player down with a higher movement cost. So the algorithm will actually take that into account when planning its path on the easiest path or the shortest path based on how long it takes to traverse the terrain, which is really, really cool, and it's so easy to implement. So you have this movement cost, just saying If it's greater than 0, meaning that we can actually move on that tile, it's not an obstacle, then let's create a node. We'll create a brand new path node, and we'll set its data to the tile that we're actually looking at currently. And then we'll just add it to our nodes dictionary here, our nodes dictionary that we create up here. Once we have a dictionary filled with all the nodes that we can actually walk on, then we come down here and we loop through that all over again, but just the walkable nodes, and we figure out what are the neighbors of that node. And we only consider neighbors that can actually be moved on. Again, we're looking at this movable cost greater than 0, meaning can the neighbor be moved on? And if so, add it to our neighbors list. And essentially this is what this is doing down here. This is a little debug, the edge count. I just have it printing down here just to see what's going on. But yeah, essentially, that's all that you do to create your graph. You just, whatever map you have, you feed that into here and it just cycles through all the tiles and creates this graph for you. And that's it. You have now a graph that you can use in the algorithm, and anything can traverse this map with ease. Really, really cool. Now, the problem that I ran into before and why I'm doing this whole week-long experiment is because I couldn't easily get all the tile information to the coordinates very simply. I would have to do a lot of extra work to get this in place, I'm pretty sure. So I wanted to see if there was a different way I can approach it. And the end product was to get this graph created. This graph is the key to a lot of things. So I wanted this graph to be able to be made simply. So that's why I'm going down this week-long journey here. So the next thing here is this big path AStar algorithm. So what we're going to do is create a brand new class here, path AStar, and I'm just creating a queue, which is going to be our path that we're going to walk to get to the destination. And all I did here was create a constructor called the path AStar. We're passing it the world, the starting tile, and our end tile, our destination tile that we want to get to. And this is the long function here. This thing right here is simply transferring the pseudocode from wiki page over to C# code. So I just go through line by line in the pseudocode, and just go back here. So line by line here, like close set, and you can come over here and look. So we have closed set. Where did I create that? See, I start here. These are just checks I moved up top of here for later on, but essentially the algorithm starts here with a closed set. You have an open set. You have the came from, G-score. And if you look back at the algorithm, we have closed set, open set, came from, G-score. You know, you just walk through each line by line, and you get through the whole thing. You know, you got while loops, you got for each loops, you got ifs, and all that kind of stuff. Just basic programming things that everyone should know about. So this is the long thing that generates, it takes this graph and it figures out the shortest path between two spots. So we're going to run that. Anytime you want your character to move, it creates this path class. It executes this path class constructor. And that's that. So, yeah, the next thing I did today was I created an NPC model and controller. So an NPC is just one of the characters. So I have some basic things in here for you know, creating an NPC on the map, and then being able to call an update function on it to change its location based on something. So right now I have a very simple, I think it's in this sprite. Where's my mouse here? There we go. It got stuck there for some reason. Alright, so I got this very simple creating of the NPC here, and then setting a destination. This is just so it immediately moves. I've also set up a cool little thing where I can hit the F1 button and it'll actually tell it to go to a location on the map, and it does that. I wonder if I still have that. I think I moved it. Anyways, I was just going to see if I had it. Oh, I have it right here. Okay, yeah, so it goes from 5.5 to 10.10. Okay, I haven't tested it going back yet, but okay, so essentially, let's just show you what's happening here. So I have this game world, and the map that's generating, I just hard-coded this map here. Let's just show you that. So in here, instead of randomizing the tile, which I had yesterday, I'm just going through and creating ground tile for this 15 by 15 map here. Um, the map is actually 100 by 100, but I'm only filling in 15 by 15. Then I go through here and I create some inside walls, leaving out some openings for doors. That's what this line does, leaves out some openings for doors. And then this loop here, actually this check here, checks if it's an edge case. And if it's an edge case, just put a wall there. So I have a wall going around the perimeter, and then I have some walls on the inside with doors in them. So very, very simple. This amount of code creates the entire map. Super simple. So here we go, new game. So here's the map that it creates, and I did update to say that the character can't move on anything called the wall. So that's essentially what's happening there. So there's no collisions here at all. Zero collision objects. These are just sprites, and the character knows that it can't walk through that stuff. It can only walk through the walls. So here is a character that was placed there. It's pretty much just a sprite of a character right now. There's no collisions on it or checking for collisions. But I'm just checking to see the pathfinding. So here's this character, and if I hit F1, it's going to try and move down to here, which is around 5-5 tile position. But it's not going to move straight through. It's going to know that it has to go through this wall here, or this door here. So it's going to go around the wall and then down. So let's hit that. So it's going to do that, and then down, and to there. Now the way that the movement algorithm is set up right now is it actually speeds up as it gets closer to the destination, which 5 minutes before I started filming this, I actually got it to move. So I was pretty happy that it actually moved following a path. It took me a while to figure out some of the bugs there, but yeah. So I'm going to clean up how that character actually moves, but just the fact that it's following a path. So if I hit F1 again, you'll see it goes back to the 10, 10, 10. That's actually where it started. It's going between 5, 5 and 10, 10. That's what this little thing's doing. So I should change that instead of being. Let's see here. Where do I change that? I changed that in the sprite thing. Yes. So instead of being 10, 10, let's make it something crazy here, like 1, 13. I think it'll have to go through 2 doors to get from 5, 5 to 113. So let's try that. So let's go back in here. Now, obviously, I haven't tested this because this is the first time I'm doing, but the path algorithm should just work and go through these doors. So come in here, new game. There we go. I'm just moving the character. Me moving up to here really has nothing to do with it, except for I want to be able to see what's going on. So I'm going to stand right here because I can see everything, and hit F1. It's going to move all the way down to 5, 5. And then the next one I told it to do is move to 113. So that's up here. It'll go through this door. Now there's no collisions on this at all. It just knows where it can travel. And obviously we can see it's cutting some of the corners and the doors, which I can clean up later on. But it's simply moving through the door there, cutting the corner, and moving down this door. So it knows that that's the way it has to go. And if I wanted to, I can make it so it can only travel in sort of 4 directions, left, right, up, and down. And that way this angling won't happen. But for now, I don't mind it. I can maybe clean that up in a little bit. Why don't we go ahead and see if I can clean that up for cutting the angles out of it and just moving in 4 directions. It should be very simple, so why don't we just try it. So in the, let's see where I, just gotta remember where I put everything, then we can do it. Okay, so right here it's getting the neighbors for generating the graph. So this true represents something called diagonal. So diagonal, okay. Now I can set that to false. Okay, so that's getting the neighbors where diagonal is not okay. So let's save that, and I think that's it. Let's go into our game here and see if that changes the way our character moves around here. So we'll go new game, go up here, and let's just hit F1. And you can see now he goes perfectly around. It does look a little odd like that. He likes to zigzag there. Let's try see what he does with this door here. Goes around, goes up, and over. So very much into the zigzagging. What I can do is check if a neighbor, if one of the diagonals is a wall. And if it is a wall, then don't include that as a neighbor. It should already be doing that, but it seems like, I wonder. I should check to see if the adjacent is a wall, and if it is, then don't go on the angle. I don't know. I'll have to fool around with that a little bit, but essentially that will clean up. Right now it's not clipping angles at all, which is great, but it does do this weird. Um, it would be nice for it to go from here to there. Just be smart and just be like, yeah, I can do that, instead of going through and clipping the angles and all that. So I think there's a cool way of doing that, and I'll tackle that another time. But yeah, that's day 23, the pathfinding algorithm implemented based on some pseudocode on wiki page. Create a brand new controller and model for an NPC character, and sort of fooled around a little bit more with map generating just using script. Um, like I said, this is most likely going to be converted over to using a comma separated file from the tiled program, and then feeding that in to generate my maps, like using some sort of an editor script. And that's what I'm hoping probably to go through, because then everything else can just feed off it just like I'm doing now. So thanks for watching. Day 2 of this week is pretty successful with the maps. The pathfinding is done. I was relieved to get that done so early in the week. And yeah, so if you feel like subscribing, please do. If you have any comments, please leave them below. And if you liked the video, please like it. And we'll talk to you guys later. See ya after on day 24. Bye-bye.